Let's have a look at question 30 in this video. So we have a production filling operation with a standard deviation of 6 grams. When in perfect adjustment, the mean filling weight is 50 grams. We may assume that the filling weight is normally distributed. Now an inspector selects at random 36 containers and uses the sample mean to see if the process is in perfect adjustment, and the sample mean is 48.6 grams. Now we have this hypothesis. Is the mean of this production filling actually 50 or different than 50? What's the p-value for this test? Now before we calculate the test, let's just understand the intuition of the question. We know that we should have a 50 grams in perfect adjustment. And to check that, we're taking a random sample to see if that's true or not. And what we notice is that we have it slightly less than 50, so it's different than 50. But the question is, okay, is this difference significant, or is it just by chance? Or by chance, meaning that if it is by chance, then if we take another random sample, we might have an actual sample mean which is gonna be close to 50. Maybe it's gonna be 49.4 or 50.3, somewhere around that range. So if the difference is not that big, then we might not reject the hypothesis. We might just still assume that the actual mean is 50. But if this difference is significant, it is so large that it could not happen just by chance, then we have enough evidence to say that probably the mean of this production is different than 50. So how do we calculate this probability? Well, literally, because it's a probability, we're using our z-test. So we're standardizing by taking the difference between our sample mean from the population mean relative to the standard error of the sample mean. Now, what is the standard error of the sample mean? The standard error of the sample mean, that's the standard deviation of the population divided by the square root of the number of observations, which is equal to 6 divided by the square root of 36. So that's 6 over 6 equals to 1. So we know that the standard error equals to 1. Now what's going to be the z-value for this test? The z-value is going to be the difference between 48.6 minus the population mean, which is 50, divided by 1. And that's equal to minus 1.4. Now what we're looking for is the p-value for this z-test. So let's solve this on a graph so that we understand better. We have the z-value of minus 1.4. We have it over here, the z-distribution. The mean is 0. The z-value that we found is minus 1.4, so we write it over here, minus 1.4. And because the distribution is symmetric, we also have a corresponding value on the other side. Now, this is the probability of having a value less than minus 1.4 or higher than 1.4. Now, if we think in intuition, in common sense, what does it mean? This is the probability of having a sample mean that's gonna be less than the average. This is the probability of having a sample mean that's higher than the average. So this is a probability of having a sample mean less than the population mean of 50. This is the probability where we would have it greater than the population mean of 50. And if we have a look at the hypothesis, we notice that the alternative hypothesis says that the mean is not 50. It doesn't specify whether it is less than 50 or greater than 50, meaning that the difference between the sample mean and the population mean might happen in either case. It might happen when it's below it or when it's above it, meaning we have to research both these probabilities. So the total p-value, the p-value that we're looking for, is going to be the p-value that z is less than minus 1.4 and the probability that z is greater than 1.4. So we're looking at these small tails together. Now, what's the probability of z being less than minus 1.4? We can calculate that. We can not calculate, but have a look at the distribution, at the z distribution, and that probability is equal to 0.00808. Now, the probability that z is greater than 1.4 is the same as the probability that z is less than minus 1.4 because it is symmetric. So we add the same probability over here, and in total that gives us 0.1616. And if we have a look at the answer key, they say that the p-value is equal to just 0.08, which is false. So the answer is false, and that's it.